In this section, we'll discuss a case study of computing a number sequence using recursion. A factorial is a mathematical term for a sequence of numbers that are multiplied together. For example, 5 factorial is the product of 5 times 4 times 3 times 2 times 1. The result is 120. We describe the factorial function as f, which is again Euler's notation for a function, and it is broken into two parts. The base case, where we solve the problem directly. In this case, if n equals 1, we know that the factorial is 1. And then the recursive case here, where n is greater than 1, we consider it to be n times f, which is the factorial function, which takes n minus 1. The problem becomes smaller. We multiply n by some as of yet unknown value, but we know that the factorial function of n minus 1 will eventually return a value. The factorial function is called again, and it may be that n minus 1 is equal to 1. If so, the base case returns 1, and then we, in reverse, do all the multiplications back upwards. If it is not the case that n minus 1 is 1, then we still have the recursive case. So it will take the value that was n minus 1, use that as n, and then call the recursive factorial function for n minus 1 again. With our example starting with 5, we would first say 5 times factorial of 5 minus 1, or 4. N would be 4. We would come in, determine that it's not 1. We would say, since it's greater than 1, we're going to say 4 times factorial of 3, and then 3 times factorial of 2, and 2 times factorial of 1. 1 is the base case, so it says my value is 1 and returns that. So 2 times factorial of 1 is 2 times 1, and it would return the answer 2. The previous call was 3 times factorial of 2, or 3 times 2, which is 6, and then returns, and we get 4 times 6, 24, and then 5 times 24, or 120. In a programmatic way, we would write our method like this. First, put the signature in place. We know it's going to return an integer, so the factorial return type is integer, and we know it's going to take an integer value as a parameter. So we get public int factorial with a parameter list, int n, curly braces for the body. Now we want to write the base case. That is, if n equals 1, we return the value 1. We write that. It's very clear. We finish then with the recursive case. If it's not 1, we're going to use the else keyword and then say return n times factorial of n minus 1. As we subtract 1 from n during these recursive calls, we keep pushing n closer and closer to 1, which is the base case. We want to make sure that the recursive case pushes or drives the next recursive invocation closer to the base case. Otherwise, we'll get an infinite recursion and our stack will overflow and our program will crash.